Hi, everyone. Today we'll discuss very simple thing counting. So 1, 2, 3, 4, 5, 6. Okay, so it seems very simple. So what we want to do is to determine size of a finite set. So I give you a set. We want to know number of elements inside set. So we assume S is finite set. So that's called counting. We just want to know the number of elements of a set. All right. Uh, I think you may be familiar with some of these things, so I will just discuss some basic things very quickly today. And actually, next week, we'll get into something more complicated, combination and permutation with repetitions. Today's subject actually very simple. Some of you may have learned it in high school already. Okay, so let me give you some basic idea first. There are three very basic rules. Almost all counting are based on these three rules. One is called the time rule, second one is called the product rule, and third one is called the inclusion-exclusion principle. All right. So first, want to deal with this situation. Suppose there are two different approaches to finish something. For example, if we want to get from S to T, there are n1 ways to do it in this way. So inside there are different ways, and there are n2 ways to do things in this way. Then total number of ways to go from S to T is n1 plus n2. It's obvious. Okay. So for example, if we consider these two, for example, one is daytime, one is night, maybe one is daytime, one is nighttime. Suppose one eats maybe 10 biscuits in daytime and the nighttime maybe 5 biscuits. So total number of biscuits per day in a day is 10 plus 5 equals 15. That's very simple. So that's some observation rule. All right. So quite obvious. Second rule is called the product rule. So in order to finish job, one can do one thing after another. So suppose I want to go to S to T, I can reach a middle point, then from middle point I do T. Suppose there are n1 ways from S to the middle point, n2 ways from middle point to T. Then total number of different ways will be product of n1 and n2. So that's n1 times n2, given total number of ways to do things. All right. So let me give you an example. For example, consider string can be formed by letters and digits. Okay, so strings say of length 2. Okay, so that's very simple. Formed by letters B and digits 0, 9. So suppose we want to start the string with letter first. So the string has a form letter plus digit. So it's length 2. First one is the letter, second one is digits. For example, A, 0, or B, 9. So how many different such strings can be formed? So it's a very simple application of multiplication of product rule. So there are 26 different ways if we ignore lowercase and uppercase. So 26 different ways to form the first character in a string and 10 different ways for the second character of the string. So total number of different ways will be 26 times 10. It's 160. All right, so this part is the rule, very simple. Okay, so let me give you a couple of examples to use these two simple rules. Okay. So just a very simple example. Suppose you want to get from S to T. Okay. So number indicates the number of possible ways. So from S to this point, there are three different ways. So from this point to this point, on this part, there are three different ways. On this part, there are two different ways. All right. So we want to know total number of different ways. So this one will be combination of product and some rule. So here there are three different ways on this part. From this point to this point, number of different ways will be 2 plus 3. And from this point to this point, when you sum rule again, it will be 1 plus 2 plus 2. So that's the number of ways. Now, on whole problem, there we use product rule. So here 3 times this one, times this one, times this one. It will give us 150 different ways. Okay, so that's very simple. All right. Okay. If we have a set S with n elements, we want to know total number of different subsets of S. So for example, if we have a set, so S equal 1, 2, what's the total number of subsets, different subsets of S? Of course, for the small one, it's possible to enumerate everything. So we know their subsets contain singletons, 1 and 2, and also set itself, 1, 2. So here there are 3. But don't forget, there are another subset called empty subset. All right, the total subset will be 4. So for this one, total number of subsets is 4. So here, actually, power set usually is written in this way. So the number is 4. All right. So in general, with any elements, what's the total number of subsets? Okay, we can look in this way. So let's ask. So we consider subset. So say X is a subset. But to form a subset, we take some element. So what we can do is consider a particular element S. Consider a particular element S with respect to this subset X. So there are two possibilities. Either S is inside, so this S inside here, or S is here. So there are two possibilities. Given a particular element S, there are two possibilities. Either it's included in a subset or not. So for each element, there are two possibilities. So we use multiplication rules. Each element, so if we name it as S1, S2, up to Sn, right? So S1 has two possibilities, S2 also has two possibilities, and so on. Sn has two possibilities, so that gives us 2 to power n. But the number of subsets is 2 to power n. Of course, most of you know this. All right. Actually, we used this idea already last week when we discussed critical principles. But the subsets, there are two subsets with same sum. Actually, we use this idea. Okay. But we count the number of subsets. Okay. So here we want to know the number of different functions from set A to another set B. What's the number of different functions? So for example, if both A they have two elements, so here I will give you a graphic representation of how function look like. So let's see, maybe even write it A1, A2, B. So this gives us one function. This one is a different function. And I can also have this function. All right, so we want to determine number of different functions from set A to B. How many are they? So suppose we're mixing a little bit easier to write. So number of elements A is M. Number of elements in B is N. All right. So what's the total number of different functions from A to B? Again, we can easily obtain this number by using product rule. Because for each element inside A, what the number of possibilities that this particular element will be assigned to a value element inside B? What's the possibility? Because A can be assigned any element here as its image. So each element has n possibilities to be its image. So suppose we write in this way. Okay. So for A1, there are n possibilities. So here's m, sorry. For A1, there are n possibilities because each element can be an image of A1. So I can assign B1 to A1 or B2 to A1. So there will be n of them. Similarly, for A2, there are n possibilities. So it will be n. All right, so that will give us n to power n. So that's total number of different functions from a set with m element to a set with n element. Okay? So here I'll give you some examples of using sum and product rules. All right. Okay. Now the inclusion exclusion rule or principle. The very basic one is with two sets. Actually, sum rule is a special rule or a special case of this rule. When A, B are disjoint, we have some rule. That's the sum rule. Okay. That's exactly the sum rule. In general, these two sets may have something in common. Then the size of their union will be summation of these two individual sets minus their common parts. So it's very easy to see. If you draw two circles for the two sets, A, B, this one will count this part twice. So that's their common part. So we need to take this one out. So that's called inclusion exclusion principle. Of course, inclusion exclusion principle deal with general case. Instead of two sets, we may have a collection of sets. In general, we need to deal with this situation. And once we know that, we can obtain this one from this one. So for example, for three sets. All right, so it can be written as okay. So then we apply it to V2. Okay, so we can use this one, right? So then this one, we'll use this one again. So this one, use distributive law of intersection and then extend it. Eventually, we'll get a formula for this one. All right. So I don't think I want to give you the final result. It's quite simple. Okay. So just minus the plus alternates. Okay. So there will be 7 terms: A1, A2, A3, then minus A1, A2, A2, A3, A1, A3, and the plus their intersection. But the key part is just really this one. Once you understand this one, then this one follows immediately. All right. Okay. So these are very basic rules on counting. Almost all counting are based on these 3 principles. Of course, it can be getting more and more complicated. So I'll give you one more example, okay, including these 3 principles, at least 2 of them. Okay, let's see. Okay, so let's consider the first 100 positive numbers from 1 to 100. I want to know number of integers from 1 to 100 that is divisible by either 2 or 3. Just a counting problem. I want to decide the size of the set. Okay, so if I write set in this way, so S. Okay, so here we consider positive integers. All right, so we want to determine the size of the set. Okay, so one way to do it is the following. We can draw 2 basic sets. Okay, so we can draw 2 basic sets. A is integer from 1 to 100 that's divisible by 2. B is integer from 1 to 100 divided by 3. Because it's easier to compute for such set. Now, of course, S is a union of A and B. So for this one, for A, it's quite easy to determine is 50. For B, 33. All right. Now, side of this one, okay. So what is this set? What is this set? Integer divisible by 6. All right. So then side of this set, A and B. There are 60, 100 divided by 6. take the floor, okay, it's 16. So total number will be D2, summation of D2, 67. All right. So that's one way to do it. Another way is this. So that's one way, okay? I'll give you another way. Okay, consider the set S, okay? Let's always assume this I. So let's always assume I in this range, okay? To save time, okay? All right. So we consider even numbers and odd numbers. The number of integers divisible by 2 or 3 will equal number of integers inside here divisible by 2 or 3, and number of integers inside here divisible by 2 and 3. So total number will be counting this one plus this one. I using some rule. So what's the number of integers? What's the number here that's divisible by 2 or 3? Because these are odd numbers, they can never be divisible by 3. So after same as number of exactly same as number of elements inside here. Two. Right. So which is exactly, but these are even numbers, which is exactly 50. All right. Now for this part, what's the number of elements divisible by 2 or 3? Number of elements inside SO divisible by 2 or 3. So these are the numbers. They can never be divisible by 3, by even, by 2, sorry. All right. So these are exactly the same number inside SO divisible by 3. All right. So how many are here? From axis of here is from 1, 3 up to 99. How many are there? Actually, it's 17. All right. So in this case, these are disjoint set. So we can use some rule directly. That give us 37 as well. Okay. So let's finish our discussion of these 3 basic rules. Of course, you need to do a lot of exercise to really understand the rule because things can get complicated. Okay. Uh, I think you learned combination and permutation from high school. But anyway, we'll go over them quickly. Okay, permutation and combinations. All right. So what we have is n distinct objects. All right. For example, S maybe A, B, C, D. Okay. So permutation deal with choose k elements from S and arrange them in order. So we want to know number of different ways. Yeah. Difference is in combination. We just only need to choose k objects. We don't order them. Ordering does not matter. In permutation, we not only choose k elements, but need to order them in a linear fashion. So ordering matters. Okay. So for this one, for example, say k equal 2. So k combination is we choose two elements from these four elements. And we want to know a number of different ways to choose two elements from these four elements. So of course, for this small one, we can enumerate our possibilities. So we can choose AB. So then BA, AB will be same thing. All right. So in combination, we don't care about ordering. So we just choose AB or AC or AD. So we can choose a BC, BD, or CD. So there are 6 different ways to choose two elements from these 6 elements. Now, in terms of permutation, once we choose them, we still need to order them. So if we just use these two objects, so the ordering will be different, BA and AB. So they will correspond to two different orderings. Okay. So that's the difference between combination and permutation. Of course, because permutation ordering matters. Number of ways is much more than combinations. Right. So in general, how many different ways to permute k elements from a set of n distinct objects? So we can use product rule to easily obtain this number. So usually we use this notation P and K. Permute k elements of n elements. All right. Now, how many different ways to put an element from S as the first element? There are n elements. Of course, the first one has n possibility. All right. Then next one, their supply is reduced by 1. So next one will be n minus 1. And so on up to n minus k plus 1. So that's the number of k permutation. So use the factorial notation that can be written as n factorial divided by n minus k factorial. All right, so in this case, n equal 4, the 4 factorial divided by 2 factorial. So, so that will give us 12 different permutations with 2 elements from these 4 elements. For this permutation, combination, of course, there are very obvious relation between permutation and combination. That is, number of different permutations. In order to do that, what we can do is first choose k elements. So that's normal notation, choose k elements from an element. Then once we choose 2 elements, say these 2 elements, there are k factorial different ways to order them. For 2, there are A, B, B, A, 2 different ways. If there are 3 elements, say 1, 2, 3. If we choose these 3 elements, there are 6 different ways to order them. Can be 1, 2, 3, or 1, 3, 2, or 2, 1, 3, 2, 3, 1, and 3, 1, 2, 3, 2, 1. But each will corresponding to k factorial different permutations. So that gives us a relation between combination and the permutation. So from here, we know that n choose k equals E and k divided by k factorial. So which is the same as the following. In this notation, factorial notation is k factorial n minus k factorial. Yeah. So another common notation for this one is n choose k. All right. So you see, these numbers grow very fast because it involve n factorial. So number of combination, number of permutation, very huge number. So that's why we have a notion called is a combinatorial explosion, simply because number grows very, very fast with n. Okay, number for n factorial grows very, very fast. So this n factorial really grows very fast. Okay, it's roughly in the order n to nth power. Actually, it's big faster than n to nth power. It's faster than this one. You see, this one grows very, very fast. N factorial is even faster, but not too far away. Okay. So that's why n factorial grows very fast, and number of combinations and permutations, even for relatively small n, this number grows very, very fast. Okay. All right. We need some example combination or permutation. Like it's not, right? Just you learn these things from high school, right? Permutation combinations. Or otherwise, so the reference book contains many examples, simple examples. It's easier to understand for the simple things. Okay. One thing I want to discuss is properties of this number, because this one is very important. There are a lot of interesting properties. We need to know, okay? And eventually we need a so-called binomial theorem. Not enough space. Okay, this number grows very fast. Okay, of course, roughly n to k is roughly n to power k. So it grows very fast. So roughly, okay. That's really grow very fast. There are some important property of this one. Then you should know. Okay. So first one is it's symmetric with respect to k and n. So it's n minus k. So choosing k elements is same as choosing n minus k elements. So to choose k elements here is same as choosing n minus k elements here. Because there are one-to-one correspondence. Because of one-to-one correspondence. So once we choose this part, its complement is uniquely determined. So there are one-to-one correspondence. So in order to choose that set, it's sufficient to choose this part. But once we have this part, then this part is uniquely determined. We just take its complement. So therefore, this one holds. Of course, from the formula, it's quite obvious. From formula, this one n factorial, k factorial, n minus k factorial. So here will be n factorial, n minus k factorial, k factorial. I'll call that correct. But there are combinatorial reason. Reason is, in order to choose a subset with k elements, we can choose a subset of n minus k elements. Then the remaining set give us the solution. So because this relation, we have this one. And the second one is the recurrence relation for this number. I think I mentioned it earlier. The recurrence relation for this one, C and K, C n minus K, K plus C n minus 1 K. We have the following recurrence relation. All right. Now, look at this set. Consider particular element X. I want to choose a set with a element. There are two ways. One is include this set. One is not include this. One is include this element X. Another one is exclude this element X. There are only two possibilities. When I choose a set with k element, either use this element or do not. If I use this element, then remaining one is I don't use this one. So I need to choose k minus 1 element from remaining set. So that will be n minus 1. Okay. If I use this element, if I do not use this element, all the k elements will come from this part. So let's give us this one. Of course, we use that we can also obtain this one from the formula, but it's easier to use its combinatorial meaning to obtain this equality or recurrence for this number. All right, one more. I want to choose two elements from a set with two n elements. Then this one equals 2cn2 plus n squared. Of course, here n will be at least 2. Okay, now what happens is to choose two n elements from this set. What I do is divide that into two parts, both with n elements. I choose two elements from a set. There are two possibilities, three possibilities. Let's see. Two elements. Yeah, two possibilities. One can say three possibilities. Either choose two elements from this side, or choose two elements from this side. So this gives us this one. So choose two elements from this side or this side, 2 times this one. Or I choose one element here, one element here. So there are n possibility, here n possibility of choices. So using product rule here. Here is some summation rule. So that's how we get it. All right. Okay. Oh yeah, binomial theorem is important. Yeah, binomial theorem I want to discuss. Okay. All right. Binomial theorem dealing with this situation. If we extend this product, we know it equals 1 plus 2x plus x squared. So how about 1 plus x cubic and 1 plus x n? In general, maybe x plus y to n's power. we want to find out coefficiency of these terms. So for a particular term, it may be xi, yn minus I. What's the coefficient here? What's the value of this one? So binomial theorem tells us coefficiency of this number. All right. So this number is determined by the following triangle. This triangle represents the previous recurrence relation. This number is summation of these two. This is the recurrence relation. Recurrence relation for C and K. The summation of these two. So each number is summation of the two above it. All right. It's selected from the recurrence relation of this one. So this is triangle. It's invented or discovered by Jiang Xian in 1050. So over more than 600 years earlier than Pascal or Pascal. In Western world, it's known as Pascal triangle, but actually it was discovered by Chinese in 1050. Later, it's noted by another mathematician called Yang Hui. This is 200 years later. So anyway, the binomial theorem wants to know the coefficiency of this one. I ran out of ink. All right. So the coefficient of the term is exactly C and R. So note the symmetric between this. So actually the term xn minus I, yi, so will be same as this one. So that's C n minus I. The coefficient, but this one is the same as this one. They're equivalent. So it's symmetric. You see symmetric here, symmetry here. All right. So why is this one the case? So how do we form this term? So consider this term. How do we form this term? All right. So what's happened is we choose I axis from x plus y to x. So there are total n of them, n of this term. So what happened is we choose ix from them and then choose n minus I y from not choose back. It's sorry. Here we don't choose. Okay, it's formed. This one is formed by I-axis and n minus I-y's. So how do we form this one? So choose I from n x plus y. Because once we choose this one is fixed. Therefore, it gives us this number. So n choose I. So that's how why the coefficient is n choose I. Okay. So this binomial theorem has important property. And that allow us to prove some very useful formulas. For example, this one, summation of all coefficients. If we sum them up, this one give us 8. So this one give us 16. This will give us 32. What the summation? Summation is exactly 2 to power n. It's a number of different subsets. Actually, the total number of different subsets. So I have subsets of size 0, size 1, size 2, and it's exactly that's a number. So that enumerates all possible subsets of different sizes. Of course, from this formula, it's very easy to obtain this one. We set x equal y equal 1. So this part is 1. This part is 2 to power n. All right. I think I will stop here. There another formula which is easy. I will just write it. Okay. So if we choose x equal -1, y equal 1, what we get is if it alternates, then it gives us 0. So we set x equal -1, y equal 1. That will give us formula. But this one is an important one. Okay. Let me say something about the midterm exams. That will be coming Monday. So start from 10 a.m. 10:30. Okay, in class. It's an online exam, and the material will cover everything basically up to pigeonhole principle last week, but may involve something simple rules for counting, some rule, addition rule, and intersection, the inclusion and exclusion rule. So these 3 rules may be included, but mainly cover everything up to pigeonhole principle. Of course, most important in the logic, recurrence, and pigeonhole principle. These are most important things. Some problems will be similar to the homework problem. If you have done homework by yourself, it should not be difficult. All right. For the online exam, it's very important that everyone make sure that your camera is working, because we need a video camera to show your face to avoid cheating. I will put details about some regulations to the course homepage. Details will be put into the course homepage. Okay. So is there other question? Oh, by the way, there is no tutorial tomorrow. The tutor will be there to answer your questions. The tutorial tomorrow will be just in connection with tutors. Okay. Okay, let me see if you have other questions. Is there anything you want to know? Yeah, you're right. Basically everything, but the emphasize maybe on a logical reconciliation and pigeonhole principle. So really you should do homework. So better to finish homework before Monday, so you will have a good idea. Of course, the visual notation, ordering of functions. Okay. Oh, by the way, the exam will be open book, open note, everything is open. Okay, everything is open. Okay, for these something that are out of my control. If we power outplay other things, I don't know what to do. Okay, it's really out of my control. So suddenly something happened like these things, I don't know how to do it. So it's really out of my control. I'm not God. Okay, anyway. Yeah, open book will not help much, I believe. Yeah, I believe so. Yeah, yeah. Only 60 minutes. You don't have much time. Okay. So Special case, you send me email. I will see what I can do. Okay. Look, it's relatively short. So you the problem will be not too difficult. 16 minutes. I think it's not realistic. I give you an algorithm, ask you to prove the correctness of algorithm. So you get the basic idea, right? But certainly, if I give you uh, a recurrent relation, you should be able to solve it. Of course, it may not look exactly as what you did in your homework. It's not fun. Otherwise, no point to overwork. Okay. Final exam, too early to talk about final exam. Okay, it's about 60 minutes. Homework, I thought they posted the homework solution already for homework 1. Homework 2, they also posted it, I think. In the tutorial, they talked about homework 2. I cannot tell you everything, like what will be in exam, what will not, but use your judgment. If there are some proofs, proof should not be difficult, otherwise time too short. Of course, there could be some proofs. All right, submitting homework will be through the system, like upload. Same as uploading homework. You will convert your file into PDF, then upload it. Right? Homework 3, yes, certainly. Pigeonhole things about there. No, I'm not saying that no proving algorithms. If there are any, it will be something simple, maybe. Yeah, custom homepage. Yeah, everything will through custom homepage. No, one asked, can I postpone deadline of homework 3? I don't see any point and the reason for that. In case homepage upload does not work, you can email to me for your answer. Okay. Yeah, it could be handwritten. Actually, I expect you to do your homework. To do midterm exam by handwriting. Like unless the system has some problem, otherwise a few seconds will be good enough to upload. I checked the last time 1 second can handle 10 or 20 students, so it should be very fast. That's 10:30 when the class starts. Yeah, some detail I will post it on course homepage. Okay, so there will be some written thing on the course homepage. Check out the course homepage. Yeah, there will be some time for you to do that. I will specify detail in the course homepage. Yeah, for example, scanning answer, of course, it takes some time. How much it take? 1 minute? Because 2 or 3 pages, it should be quite quick. Yeah, I will give you some time to get things done. I expect you to use handwrite to avoid the cheating, to be honest. For percentage, it's about 30%. I will post them later, okay, in the course homepage. Because the time, uh, there's something you don't want to know because different sections, different people have different opinions. So that gets things. So usually how much time it takes to convert into PDF file? Should be very quick. No, it must be joking. 20 minutes, 15 minutes for scanning. No way. No, the format should be same as the homework format, PDF file. Everyone, it works for almost for everyone, right? No, the problem if that's the case, not it's not there for other students. 15 minutes. So some who knows whether you are scanning or you're still writing. And not matter what other course are doing. Okay. The answer at most maybe 2 or 3 pages. Okay. So normally how much time it takes to scanning one page for you? Half a minute? 5 minutes for one page? No way. You must be kidding. Now, let's say for one page, how long does it take to convert into PDF file? One page to five? No, I don't have experience for that. So I really would like to know. You take picture, that's 2 seconds. Yeah, all technical problems can happen. So we cannot predict everything. How can take photos takes 2 minutes? Okay, I get the idea how long it would take. Okay. Yeah, unfortunately, if these things are out of my control, I don't know. And university does not tell me how to deal with these things. I can only do my best. Okay. Okay. So I will put other things into the homepage. I get the idea. Okay. What I talking? You go ahead. I am not saying I just give you 1 minute. If you want to complete, go ahead. You are saying don't have camera. All right. Okay. So check out cost homepage. Beware of the university policy about cheating. The penalty will be very severe. Not only failure of course, demerit, also maybe downgrade from other class. All right, we are very serious about cheating in exam and homeworks. Yeah, I'm not saying I giving you 1 minute. Okay, I just want to ask you like how long you will take. I will certainly will give you reasonable amount of time to upload it. Otherwise, if you cannot upload things, so midterm means nothing. Of course, I understand these things. All right. Okay. So that's for today. Okay. Bye.